Hey guys, so I'm going to do a quick video on how to prepare solutions. So there's two different ways that we can prepare a solution. The first is preparing a solution from a solid. So if you go into a cabinet in your chemistry classroom and you see that there's a solid there and you need to make a concentration or a molarity of something, there is a way that I can make that concentration from this solid. The way that we do that is by using the molarity equation that we learned in stoichiometry. So our molarity equation is moles over liters. So an example is, what if I wanted to prepare a 500 milliliter sample of 0.2 molar solution from this solid? What I'm going to do mathematically is I'm going to have to first figure out how many grams of this is needed to make my 500 milliliter 0.2 molar solution. So the way that I do that mathematically, make sure your milliliters is in liters and plug that in there. Your molarity gets plugged into here. So if I take molarity times my volume in liters, does that make sense that that's going to give you the mole amount? So by multiplying molarity times volume in liters, that gives you how many moles of this that I need to have. Well, since it's very hard to measure out moles, we don't have a device that measures that out, we then have to convert this to grams. So this is again stoichiometry, where we convert those moles, we convert them to grams, so that way we can measure this out with a balance. How we convert moles to grams is just our dimensional analysis, where we use the molar mass of NaCl to do that. So that is the very first thing we have to do whenever we're trying to prepare a solution. We need to figure out how many grams of this stuff that we need to measure out. After we figure out how many grams we have, we then follow these steps. Now, something very important to note, I want to make sure that you do write this down in your notes, because they love to ask this on the AP for your response portion, where they want you to list every single step that you need to do to prepare a solution. So I put every step, especially those things that are underlined, we need to make sure that we have. So here's our first step. We measure however many grams we calculated from the equation of solid NaCl. We have to say what we're measuring it with. So we're measuring it with a balance. So we put this, measure it out on a balance like so, okay? Once I have that amount of solid measured in my balance that I calculated from here, I then add this to a 500 milliliter volumetric flask. Anytime we prepare solutions, this is the type of glassware we must use. This is called a volumetric flask. If you see, I'm not sure if you can see in the video, but on these volumetric flasks, they all just go with one volume, and that volume has a little ring around the neck on the flask. This mark right here is called a calibration mark. So we use volumetric flasks, we're adding that solid to the volumetric flask, okay? Once I do that, I then need to make sure that that solid dissolves in here. So we're gonna take DI water, which stands for deionized water, and we're gonna add enough DI water, not all the way to that calibration mark yet, but we're gonna add some DI water. I usually like to add it to right here, middle of the way through the big end of the volumetric flask, and we stir to dissolve that solid, okay? So that is our second step that we do. Once that solid is fully dissolved, now it's time to fill our volumetric flask up to the calibration mark. So we're gonna keep filling with our DI water. The DI water is important so we don't create any precipitates that's not supposed to be there. And we're gonna fill up until we see the bottom of the meniscus at this calibration mark here. So that is the proper steps that is needed in order to prepare a solution from a solid. So make sure you have these written in your notes. You will be making a solution at some point in a lab. The second way to prepare a solution is if we do not have a solid on the shelf, but instead we have a stock solution. So this is already a solution, it just might be a higher concentration than what we need. So an example problem would be prepare 500 milliliters of a 0.2 molar solution from a 1 molar stock solution of NaCl. So a stock solution is something that's already a solution, not a solid, but it's at a higher concentration than what we need. So we want to be able to basically dilute this 1 molar stock solution to make a 0.2 molar solution. How we do that is we use this equation. This is called the dilution equation, M1, which stands for molarity, V1 for volume, equals M2 V2. This is the second molarity and the second volume that we're trying to make for our new solution. This M1 V1 is of our stock solution. This M2 V2 pertains to the new solution that we're trying to create. So what we're gonna do is we're gonna plug the molarity of the stock solution in for M1. We're gonna plug the molarity for the new solution in for M2, and we're gonna put our volume of the new solution that we want to create. So that would be 500 milliliters plugged into there. Now we just use algebra to solve for that unknown volume. So what this unknown volume is telling you, how much of this volume we need to measure out with a graduated cylinder to create our new solution, all right? So once we have calculated this new volume, we measure that volume of stock solution with a graduated cylinder. We have to make sure we specify that type of glassware, the type of equipment that we use. Once we have measured this amount that we needed, that we calculated in the graduated cylinder, we then get to add this to our volumetric flask. Once again, we're using a volumetric flask to prepare our solution. Once we now have this volume of solution inside our volumetric flask, we can just go straight to adding enough DI water. Again, we're adding enough DI water to reach that calibration mark. So this is how we prepare a solution from a stock solution. This is how we prepare a solution from a solid. We are going to be doing this in lab and seeing how close we get to the right answer. So hopefully you guys have these written down as notes so you can do well on that. Catch you later. 6, 7.